Welcome to today's webinar entitled Air Vents and Corrosion, New Requirements for the 2016 NFPA 13. My name is Billy Zadig, Manager of Special Projects for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage later this afternoon. You'll receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We will close out the 2021 webinar season on November 17th. We will pick back up in mid-February 2022. Professional continuing education and AIA CLU credits are being offered for today's program. If you are an AIA professional requiring a certificate, please send an email to me at Billie, B-I-L-L-I-E, @apa.org, along with your AIA membership number if you have not done so in the past. All attendees are in listen-only mode. Please type your questions in the chat box, and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. If you're just calling in, make sure to send me an email at billie@apa.org so I can send you a certificate if you requested one. The system only recognizes you if you log in. At this time, it's my pleasure to turn this over to Jim McHugh, our speaker for today. I will rejoin you for the Q&A session later. Jim, take it away.
Thank you very much, Billie. I appreciate it. Good afternoon, everyone. First, let me start off in welcoming everyone to this presentation. We're going to be discussing products for both wet and dry fire sprinklers, with the initial focus of the presentation on new code requirements that affect all college campuses around the country for wet systems. I'll also be, at the end of the presentation, covering the impact of some recent code changes and product developments on dry systems. I'd like to thank Billie and the rest of the staff at APPA for this opportunity to speak to your group. At the end of my presentation, there will be some other information on personalized training that AGF, as well as some of our industry partners, that we offer for in-person training as well as online training, where we give different accredited classes covering a variety of topics in the wet and dry fire sprinkler systems. As Billie had mentioned, and if at any time during this presentation, if you have a comment or a question, there is the chat function, and I'll mention this a few times just because I think it helps to remind people that if you run into some form of, you want clarification or greater detail, in addition to this presentation being made available, if you would like greater details on code explanation that I'm going to cover, or any specific products that you happen to see that are part of the slides that I'm talking about, if you write that in the chat screen, there are members of AGF Manufacturing, as well as some of the other products that other companies manufacture. We can get you the relevant information you seek. And as Billie had also mentioned, at the end of this presentation, we'll be going over any questions that you submit. So getting into the meat of it here, and this presentation will go approximately 40 minutes, 42 minutes from now, and then I'll open up from the Q&A side of things. A brief blurb about me. I don't like the big introductions. I'm just going to scan it down. I've spent my entire working career in the automatic fire safety business. We're a family-owned company, multi-generational. We've been making products for this fire sprinkler industry since the mid-'80s. We're very proudly primarily a domestic production facility. We're not having a lot of the supply issues that some of the companies that import everything. And then, of course, the products that I'm going to be talking about today are where applicable, are both UL certified and FM approved. That's another big thing. Those are the two guiding safety standard and quality control criteria for the fire sprinkler industry, our Underwriters Laboratory and Factory Mutual. And we very proudly, our products comply with and or exceed any and all of their standards. From the products, now again, I'm going to be focusing on air vents, but to give you a sense of what AGF as a company makes is In almost all of your buildings, you are probably familiar with products called inspector's test valves. If you go into the stairwells in your buildings, you'll typically see a red-handled valve that says inspector's test, or it says main drain. This would look like the valves you see in the upper right-hand corner of the screen. That product was invented by my family 30, 40 years ago. And then we have different products across all the different facets of the fire sprinkler industry. In today's presentation, I'm going to be making specific references to NFPA, the National Fire Protection Association, to their codes and standards. And this is now a disclaimer they want for all the CEU accredited classes, that anything I talk about in these presentations is my interpretation. First and foremost, I think everyone has been bombarded for the last several, probably years. It's been with talking about corrosion. And I don't want to bore everyone with getting into the deep science of corrosion. I think that it's unnecessary at this point. If any of you remember leaving your bicycle outside when you were younger and your father got upset, you know if you leave air and steel and wood are in the same environment, you're going to get rust. And that's really what that oxygen-related corrosion is, what is having such an intense impact on all wet fire sprinkler systems. Corrosion is a problem in all systems, be it wet or dry, but in this case, I'm going to be focusing on wet system-related corrosion, and then I will be talking about some dry system issues towards the end. And why corrosion is a big concern is because, first and foremost, these are life safety systems. So we as an industry are very proud of our record of fire safety and life protection. We don't want to see anything, be it through ignorance or through possible contamination of a system or anything that will impair a system. So we're always concerned about, what can affect the flow and the function and the efficiency of a fire sprinkler system. So that's why corrosion is such a big topic to us. And now that, and certainly as everyone can agree, over the last 20 to 30 years, we've seen the standardization of fire sprinkler life safety systems, protecting just millions and millions of lives and covering countless square feet of property. But from all the empirical data of installation, what we're seeing is the corrosion is a big issue, and it can be handled in a variety of ways, and from good product design to good system layout and design and installation, and in addition to that, an adherence to the standard practices as defined in NFPA 25, the inspection, test, and maintenance of system. And this is an ever-increasing document that focuses on the proper handling of system. In addition to this, there are labs around the world, UL and FM and VDS, which is the European equivalent of UL, that are doing long-term studies on the impact of corrosion on wet and dry systems. VDS did one, and in this, they showed that more than a third of systems were impacted in their first 25 years of existence. It has been a rule of thumb in the fire sprinkler industry that system design were in 50-year increments. But we're discovering that through a variety of causes, it could be thinner wall pipe, or it could be, that's one of the bigger issues, it could be system design and layout, that we're not seeing nearly the anticipated longevity in systems, and corrosion is having a big impact on that. When we talk about what are the costs, and I think that's an important thing, is there's no price to put on a human life, but so first and foremost, we don't want to be negligent in the fact that we are always talking about life safety systems, but there are costs, and there's cost to install the systems, there's cost to maintain the systems, and there's significant cost that if the systems fail in any way, certainly you don't want it in the case of a fire, but you don't want corrosion to be an issue because the related costs of that. There is a national association called NACE, the National Association of Corrosion Engineers, and they have done numerous studies on mechanical systems in commercial properties, like college environments included, and that what they've discovered is that this corrosion cost can lead up to significant bills. I mean, the number that they throw on mechanical systems is $58 billion a year, which to me is just an amazing sum of money. That's 5 times the annual value, say, of the entire sprinkler industry. is just what could be the attributed cost to corrosion-related issues. And it goes with some common sense that if you can get air out of your wet systems, you'll cut down on that corrosion, because again, corrosion is going to be air, steel, and water in the same environment. So we know if we can get air out of a wet system, or we can get water out of a dry system, we're removing one of the three legs of the tripod of corrosion. So let's focus on getting the air out of the system. Factory Mutual, which everyone I'm sure is very familiar with, did a very good long-term study on the effects of corrosion. And this was looking at corroded systems to see what MIC corrosion was, microbial influence corrosion. And this is something that was initially talked about many years ago, and everyone was concerned about MIC corrosion. And then that is, over the last several years, that has, they've stopped the focus on just MIC and are talking more in a generalized format of corrosion. And in this FM study, they said that it's really 10 to 20% of corroded systems are affected by MIC. But that means that 80 to 90% of those corroded systems are affected by more generalized corrosion. And that's really, if we can get the air out of these systems, that will have a big impact. People ask me when because they think this whole requirement to add air vents to system is new, and I said no. It entered the language in code in 2007, and as we all know, it takes many years to get information into the code. So it started in conversations back in the late '90s, early 2000s about as we were getting more and more empirical data about the effects of corrosion on systems. And one of the first changes was the relocation allowance, that the remote inspector's test valve could be relocated back to the inbound water supply as long as it's downstream of a flow switch, so that as to not introduce new air into the system when the inspector's test valve is activated. And that language has carried through. As we know, NFPA 13 which is kind of the Bible of the fire sprinkler industry, and it has repeated this language every 3 years since the 2007 edition. After the 2007 edition, in 2010 and 13 was the first time that they added language suggesting that every care should be taken to remove as much trapped air out of a wet system, and if possible, add some form of manual or automatic air vent to get this out. And this was a recommendation. So in the code development process, unless it's an emergency type situation, there's typically language submitted to the various approval authorities. It takes multiple years to get into the engineering and standards code, and then it typically may start out as a should, like we recommend this as a best practice that you should do something, and then that can get altered all the way up to a shall. So really in 2010 and 13 was the first mention in code that all wet systems should have some accommodation to get the trapped air out of the system. And then as that language grew, a committee was put together, and they suggested taking the should language and making it shall. And I'm not the kind of presenter who likes to give a specific reading of slides, so I'm going to paraphrase it. But the two takeaways on this from Chapter 7 and Chapter 8 in NFPA 13 is all wet systems shall have a single air vent, and that single air vent per system shall be located near a high point, and that the air release mechanism can be one of a few different ways: a manual size valve, an automatic air vent, which is far and away the most popular one, or other means. But the two most important things are you need to have one for each system, and it has to be located in near a high point in the system. And in our industry, for the fire sprinkler industry, when they use the word shall, that means you have to do it. It's not a recommendation. It's not a best practices. Each and every system must have this. And we all know that there was no way to get all of the air out of the system. We need some amount of air in a system to handle thermal expansion. That's why there's pressure relief valves on systems. You do need, because of thermal expansion, a little bit of an air buffer to protect the sprinkler head mechanisms to allow for this. So we knew we were never going to get all the air out of a system, just trying to get as much out as possible. And one of the items of concern has been the recent update in language. And this is another thing where an AHJ or your various approval authorities have got to be on the same page with the designer and the installer on how they are defining a system. NFPA 13's latest definition of a system, again, to paraphrase it, is if you can control the flow of water, sense flow of that specific water, and drain that line, that is a system. So you could have someone interpret the drawing you see on the screen as being 3 independent systems. Historically, that may have been looked at with when you have a single backflow preventer and a single alarm check valve as one system, but more and more we are seeing across the country that that is being interpreted as 3 independent systems. That's the case, therefore, you need to be very careful about what products are required to be installed, their location, and their effectiveness. So again, back to the 2 most important shalls. And this is really when I'm speaking to building owner and management associations like yourself, people that have long-term vested interests in the properties that they own, how they are serviced, how they are maintained, and wanting and having a significant expectation of longevity in that system, as long as their best maintenance practices followed. The critical thing is you shall have a single air vent on every wet system now, and it shall be located near a high point. There is, of course, some shoulds, and these shoulds are the things that I try and point out to building owners and operators to make sure that when the person is designing or installing it on your system, and you make the assumption that they are doing it correctly, well, it's actually in print what they should be doing. So if the shall says they have to put in a single air vent, the shoulds are to make sure they do it correctly. Like they should locate them where they'll be most effective, not where they're going to be the most convenient, where they're going to be the most effective. And when you're locating them, you want to locate an air vent on the top of horizontal pipe because that's where all the trapped air accumulates. And that if you're going to put in an automatic air vent, which is far and away the most popular one, you may want to avoid putting it above a drop ceiling or some other structure because all automatic air vents are required to have strainers to protect their mechanism. And NFPA 25 requires in cycle that you be able to clean, flush, and verify the condition of the strainer. So it's just meant as a matter of convenience. There are some things that are not required. And this is probably the most frequent grouping of technical calls that I'll get from a building owner, or I'll get from a design engineer or a contractor telling me, asking me about what is and what isn't required when it comes to these mandatory air vents. And first and foremost, you're not required to put any additional drainage piping off of an air vent. There is this misnomer that the air vent itself will spray water, and that's not the case. They release air, they don't spray water. So you're not required to have any form of additional drainage. And secondly, and this is really due to some marketing efforts of people, you're not required to have any form of redundancy, like one air vent feeding into another. This is really a methodology used by a manufacturer to just sell more air vents. So having one air vent feeding into another air vent, they feel is the best practices. But if you didn't have faith in the first air vent working, why would the exact same air vent in series work any better? So you're not required to have any redundancy in your air vent nor any type of collection bucket or item around it. You're not required to have them a specific distance from the floor. I've seen some specifications where they said the air vent shall be located at the highest point. Unfortunately, the highest point of a building may not actually be the best place to locate the air vent. As I said, most installs are air vents that have strainers on them, and those strainers have to be accessible. So you want to be very careful that you don't locate the air vent where it can never be reached. So the highest point in the building may be a difficult location. And then lastly, you're not required to perform any form of discharge calculation, guaranteeing that the amount of air volume you remove from the system at like a specific percentage. This is some specifications I've seen going around the country that are wrong. They're confusing the nitrogen purity standards with the amount of air that can be removed from a system. Now, most major jurisdictions, when we produce these maps, kind of the minute we make them, they're almost dated. So most major populous jurisdictions around the country now require air vents on all wet installations. In addition to what is shown on this map, besides state mandated installation requirement, most major markets, even if your state level does not require it, most major markets and establishments such as the retail trade, the wholesale and distribution industry, they've mandated it regardless of state code, just because they know by cutting down on corrosion they're going to get significantly, they have greater longevity in their sprinkler system. NFPA 13 in 2019 did add a fourth option, adding on the allowance that a remote inspector's test valve can be a viable air vent. This was somewhat of a mistake, and it's being corrected now. So we try and point out this actually put in a contradiction into the code, because in the beginning of the same chapter, it said that having a remote inspector's test actually introduces air to a system, doesn't remove it. So the reason is inspector's test valves typically are combined with drain valves, and they could be located at the inbound of the system. They could be located off a sectional floor control in a multi-story environment, or they could be fed from the bottom of a pipe. And in all three circumstances, these would trap air above them and not release any air. So that's not good. One of the issues I think that is people get concerned about is, well, how many air vents do I need, and where do I locate it? And I try and get back to the pointing out that you are only required to have a single air vent, and that single air vent shall be located near a high point in the system. It could be at the top of a single branch line, or you could put in a common vent header off of, depending upon the peak and pitch of your roof. In Factory Mutual's data sheets, they show it with a common vent line, but that is actually not a requirement. One note of concern, so in the upcoming NFPA 25, which is typically a building engineer and a building contractor that put in these systems, hand the building owner the NFPA 25 book when they commission the system, and the best practices for our industry are all detailed in there. The NFPA 25 is the inspection, testing, and maintenance of fire sprinkler systems. It's the day after you put the system in, it's everything you're supposed to do to keep it in top shape for the lifespan of it. And one of the issues is they have just recently are adding language that you will be required to test and inspect your air vents. So that's something I bring to your note, especially if somebody was going to make a mistake and put it in an inconvenient location. Getting back to what the actual wording says, again, a single air vent and near a high point. So let's get into who makes the air vents. I think it's best to show you some different aspects of who makes it and what their products look like, just to give you some familiarity with this. I felt it's always better when building owners and managers just get a general understanding of the products, the mechanical products that go in their buildings. So it could be as simple, and number one was a manual valve 1/2 inch and larger. And these can be located at the top of the supply pipe, the standpipe. It could be located at the end of branch lines. It could be located on the top side if you have a single-story building, as long as it's near and fed from a high point in the system. Again, the whole goal about having a manually installed valve is one, making sure every time the system is serviced, which would introduce new air to the system, that those manual valves are opened to release any trapped air that comes in. One note of caution, if you are going to allow manual valves as air vents on your system, is we highly recommend that you note somewhere on plan or somewhere in the building and or near the general information sign, or in a location that is easily visible for where these manual valves are located. It can be very problematic if you have installed manual valves and have not provided their location, since they can be kind of small. And again, if they're installed near a high point in the system, they're not going to be easily visible from the floor. So you're going to want to make note of where these valves are located if you expect someone to actually be able to manually operate them. AGF does provide a product. We're one of the ones that makes a purpose-built manually operated valve, and it's kind of semi-automatic. It has 2 balls in it. The first Teflon float ball that is between the main ball of the valve and a screen strainer to protect it. What happens is when you turn on the water, that Teflon ball, when the Teflon achieves the buoyancy, it floats up into the main ball and it seals itself closed. It is still a manual valve. You can still rotate it from on and off to release any trapped air, but you'll stop it from flowing water out like a fountain once the water comes up to it. So it's kind of a semi-automatic manual air vent. And there are a handful of manufacturers who are making automatic air vents. As I said several times in this presentation, the automatic air vents are far and away the most popular way of doing this in the system. It's about a 50-to-1 automatic air vent versus manual air vent. So I did mention manual air vent, but I would tell you most everyone just puts in the automatic air vents. And different manufacturers have different ways of doing it. First and foremost, you'll notice, and it doesn't matter who the manufacturer is, from Potter, United, Southtech, or ECS, they all have a very similar design where you have some form of Y strainer device. You may or may not have an isolation ball valve before the product to be able to isolate it from the system. Those manufacturers all use Y strainers, and they all use the same air vent mechanism. So there's a lot of commonality between those 4 manufacturers of products. And where you typically see these installed, again, you can see them at the top of standpipes. You can see them again off your branch lines. So getting into some of the specifics on the manufacturers, just because you may see these in your building, so I thought I'd give you a heads up of what's out there. Southtech Industries has, again, a simple manual one. It has an isolation valve. It then has a Y strainer, and then it has the air release valve. Reliable Automatic Sprinkler has their AAV unit. They recommend in their installation instructions that you add an isolation valve. They use this a Y strainer. As you can see, it's an inverted Y strainer. So you have to be cautious about the installation of that. One of the major in the shoulds is to make sure that anytime you are installing an air vent, you absolutely have to make sure the air release mechanism is installed vertically. It can't be off the sidewall of the pipe. It can't be installed at an angle because things do not float well sideways. So it's very important that when you make sure the contractor has done their job rightly, the engineer has done their job and designed rightly, that the air vents have to be installed in a vertical orientation. Potter Electric Signal, they offer a couple different. They have their PAARB. Again, you'll notice they make a recommendation that you should put an isolation valve on it. They have their Y strainer or union connection up to their automatic air vent. And in their drawing, their automatic air vent gives you a good cutaway of what's going on inside their unit. There's a stack of 3 floats with a center rod, and then what happens is as 2 of the 3 floats achieve buoyancy, they push up on the 3rd float, and by that action, it pulls down on the rod, which closes their air release mechanism. So they had a good cutaway picture for everyone to see. They offer an additional version, the PAARB, and it's in the event that they have a catastrophic failure of their automatic air vent. The collection bucket will fill up with water, and then they have a secondary valve that when the valve is completely submerged, the interior component inside that valve will turn into a solid and close up that line. And then once you are able to address it, you have to remove all those items, dispose of the valve, and install new valves. ECS offers a collection of parts here. They've got an isolation valve, so they do include an isolation valve, a union, a Y strainer, and then now they have one air vent feeding into another air vent. United, very similar to the Southtech unit. The only difference between themselves and the Southtech unit is they actually have a dielectric union on those. Then you have AGF Manufacturing, where if you notice the similarities with all the other manufacturers, how I went through them, they all look very similar. Then you get to ours. AGF Manufacturing, we make fire protection specific components. So we pride ourselves in, we make products just for the rigors and the requirements of the sprinkler industry. We're not taking, say, bits and pieces from the other industries. So first and foremost, we incorporate a 1-inch isolation valve into the body of our lower valve. The advantage here is we knew you needed it. There's no reason to recommend it and not include it. So we made it integral to it. And then the whole body of our valve is a strainer screen. And then we added, which no one else has, this garden hose cap and chain purge valve. Again, knowing that if you have a strainer, an NFPA 25 requires that you clean and flush your strainer, we figured it'd be most convenient for all involved if we automatically put a flush valve with a garden hose cap and chain clean out so they could do that. Acts as a great location to do the initial air purge on the system or to be a vacuum breaker for your large system. So this singular bottom valve, then the center line of it, feeds up into our automatic air vent. You'll notice ours is different than everybody else's. We use a single conical float inside ours. It's in a sealed chamber, and we have a unique propeller-like device at our inlet called the bubble breaker. And what this does is it takes the large air volume and breaks it into much smaller air bubbles that go around our float mechanism. But this entire sealed chamber moves up as a cartridge. So we don't get any chance of water coming out of our unit, because as the water accumulates underneath our unit, it pushes up on the cartridge, and that's what seals our unit closed at the bottom versus sealing it up at the top. The most popular version of the AGF air vent, automatic air vent sold is the 7930 ECA. And this is very popular because it comes pre-assembled onto a grooved end cap. One of the biggest concerns when they're putting in an air vent that causes a lot of installation errors is the tight space requirements from the top of the pipe to the bottom of the roof deck. Like I've said, it's essential that air vents be installed in a vertical format. So we were challenged with making a unit that would fit, especially on ESFR, large distribution warehouse systems. They were the ones that said we had to keep it in a very tight footprint. So by having that installation, this methodology, we can fit in under 5 inches of space in height. Second, another unit we make is the 7950 ILB, or Inline Air Vent. This is give flexibility to the designer and the contractor to where if they're not really sure where they're going to locate the air vent on the system and they need just a little bit of flexibility, we give them this relocatable air vent. It can be installed in the center of the line. It makes its own artificial high point, or it can be installed at the end of the line and you just put an end cap on it. Little chart showing you who's got approvals and who doesn't. For the most part, everyone has some form of approval on another product. There's a couple of us that we have approval across everything. Probably one of the biggest advantages is we carry all the approvals in all the different sizes. We're the smallest unit, and we don't need an extra hanger like the other people do. Okay, so this was the learning objectives, because it's important when we do presentations like this. We have some very basic learning objectives. So my hope is, and again, I'm not going to read these out. I'll let those of us that are participating in this webinar just take a quick scan of it. And if you don't feel that I covered these topics, or if these learning objectives raised any questions, I would ask you to throw that in on the chat screen on your GoToWebinar control panel. You can put any comments or questions or thoughts and how we can go into greater detail on this. Rounding third base and heading home in our presentation today, I did want to talk about, and this is for freeze and flood protection. I think it's critically important, especially if we can all think back to what happened last winter in the Texas, Oklahoma, Tennessee, even the Panhandle of Florida, parts of Alabama, with just the flash freezing damage conditions that affected college campuses all over the South. And of course, the North is used to it, but this really affected the South unexpectedly, very quickly last year. So there are products that are available. They are called heated low point drains, and we now make a few different ones. We have a whole line, and you can go to collectanddrain.com and see some of the different styles of low point drains that we make. But we have some that will literally drain themselves. We have two. This first one is a mechanical methodology. It's called self-maintaining low point drains. So once it gets to a certain amount of collected water volume inside it, for every additional drop into it, a drop can drop out of it. So it always has some amount of water in it. But it comes like our other collect and drain products. It comes in a heavily insulated steel, all Kia-like heated cabinet. It does have alarm functionality on it that if the system was to trip and flood, it will chirp and blink locally, as well as send trouble alerts to your fire panel or your building management system, telling you that the unit is completely full, but it is a heated cabinet, so you don't have to worry about it freezing and breaking. In addition to this mechanical methodology of self-draining, we also offer a fully electronic methodology. So we do offer electronic self-draining low point drains. So for those of you that have any dry or pre-action systems in your building, you've all probably experienced some related issue to going around and dealing with the low point drains. We do now offer a complete line of self-draining low point drains. Now, as I alluded to earlier with what happened last winter with the systems freezing and breaking in parking garages and in, say, larger, a lot of the athletic facilities. I knew 2 or 3 colleges had severe breaks in their athletic facilities in the concourse areas. So we've just introduced a product called the Model 5900 Flood Eliminator. This is a device that gets installed on the top of a low point drain that if in the event there is a freezing and breaking condition on your system, which would cause the system to flood, these units will slam closed and prevent the catastrophic flooding, like we saw on the news. So if there's any type of freezing and breaking downstream of this product, the water velocity and the loss of the air pressure below the product will keep the item closed. Once the system pressure is reestablished, then this unit will spring back to open, act like a standard collection and drain valve. But that's called our Flood Eliminator. As I talked about in the beginning of my presentation, we do offer a variety of in-person training. We have a facility just outside downtown Philadelphia. We're about 20 miles outside the city, where we have classrooms. And in this facility, we have all of AGF Manufacturing's products. We also have all of General Air. They are the country's largest manufacturer of compressors and nitrogen generators for dry systems. So our combined, we have this great training facility. And in that training facility, you'll see pictures in a minute. We also have all the other industry manufacturers of wet and dry valves. And we all partner in this facility to provide in-person training. We offer half-day, full-day, and multi-day training. We have a complete line of virtual training like we're doing today, but if you ever want to we offer some different training formats. We have a really good one we call flash training. It's a 15-minute hard stop, 5 or 6 slides. We also have another one that we do in partnership with Grubhub, where we get either breakfast or lunch or dinner delivered to your facility or your remote workers so that they can complete CEU accredited classes while they're eating. And then, of course, we can, of course, customize training. This shows you some pictures of the training labs that we have, and it's become one of the most popular training facilities on the East Coast of the country. Now we're getting into some of the more boring details about AGF. I say that to my marketing department, but we are on all the various industry popular websites for our pre-written specifications and all of our drawing files for layout. We're, of course, on all the different social media platforms. COVID, we had to enlist some very unique help in COVID, and that's Testy McSprinkles. He's a good fan of the marketing department. And with 4.5 minutes to spare in my timing, I have hit the end of my presentation. This shows you some of the different product lines that AGF Manufacturing proudly makes and offers to all the colleges, campuses around the country. We're going to get into the question and answer section now. I think Billy, if she's going to log back in a minute.
Yes, we do have questions coming in. Our first question is, do the codes have any requirements for marking air vents installed on sprinkler systems? This may be an important issue since requirements for air vent installations are relatively new and not all maintenance or service personnel might be familiar with their intended use.
So as of right now, there is no signage requirement in NFPA 13 that you are required to indicate if a system has an air vent or not, and where, of course, that air vent is located. I can tell you that there has been discussions on the code committees to add that language. NFPA 13 is in one of its rounds of comments for public input, and there has been public input suggested that there be some form of signage requirement similar to what you see with the hanging chain of inspector's test valve or main drain or alarm valve, where you see very simple signage. that there be some type of signage on a system. But as of right now, there is not a requirement.
Okay, thank you. Our next question. What if I can't access the highest point in the system?
Perfectly worded question. So when the technical committee came out with this, to give latitude to the contractor, the design engineer, and the building owner with the expectation that NFPA 25 was going to require someone to actually service these air vents. The language was written in NFPA 13 that says a air vent shall be installed near a high point, not at the highest point. So this gives you, this purpose ambiguity gives you some latitude to locate the air vent where it will be as effective as possible. It does not have to be at the highest point, just near a high point.
Okay, thank you. Our next question. Are you seeing much retrofitting of the systems with the air vent?
So the retrofitting has predominantly been done by the large, I'd say large campus owners. So this would be people like all the Walmarts in the country, the IKEAs, Costco's, Bed Bath & Beyond's, Home Depot, Lowe's, the distribution centers for all of those companies, a lot of stadiums that have wet and dry system combined, parking garages that have wet systems in slightly cold environments. So people that have been affected by corrosion in the past are going back and adding air vents when they are typically in a retrofit. They're typically incorporating the retrofit when they're doing some other form of service work on the system. They're adding an air vent. These devices are very easy to retrofit onto a system. As I said, if you looked at our model 7930 ECA, it's the equivalent of just pulling off a grooved end cap and putting this on as your end cap. So it can be done very, very quickly.
Okay, thank you. Our next question. Can air vents act as a vacuum brake?
So it's funny, this has come up a few times. We had a contractor in Connecticut pointed out to us. They were doing a large facility, and they were having an issue that when they would drain down this very large facility, sometimes they would pull a vacuum on the system and dislodge a coupling. And they noticed that after installing our air vents that this problem stopped. So the air vents, the minute you initiate the drainage of a building, the air vents, of course, are going to lose their seal, and they're going to allow air to come through them backwards. But it's a very small orifice. It's only about a 60,000th orifice on the outlet, which would become the inlet for the air coming into the system. This is one of the reasons why we added that purge valve. You could open that up when you're draining down the system, and it would act like a very large vacuum breaker. But yes, a standard automatic air vent, not a manual, an automatic air vent will act as a vacuum breaker if necessary to help drain down systems faster. Good question.
Okay, thank you. Looks like we have one more question. Do I need to pipe air vents to a drain?
There is no requirement to have any additional drainage piped to an air vent. There's nothing stopping you, and all of the air vent manufacturers, all of us, do provide connections on our vent mechanisms for the attachment of drainage piping, or in our case, we offer additional products that you could install on our air vent that would give you either a mechanical or an electrical connection at the outlet of the air vent if the air vent's in complete working order. So all the different manufacturers all do provide a threaded connection off the air vent if you wanted to attach something to it, but it is absolutely not a requirement. So that has been a point of contention between building engineers and contractors, where the building engineer says you have to do it, and the building contractor looks at the code and says, well, code says I don't have to do it. Ultimately, it gets down to what do you really want? But there's no requirement to have additional drainage piping.
Okay, our next question is, do air vents fail? And if they do, what is the result?
Well, I mean, they have a relatively good safety record when it comes to failing versus not failing. They've got a, in the case, their history, the air vents themselves, if you looked at the ones that I think I showed you, 4 or 5 manufacturers that were all using the same air vent, they're all getting it from the same manufacturer. That came from the boiler industry, and that air vent is the one that has the stack of floats in it. And any air vent is going to when it's venting out air, if you were to put your hand right up against it, you may see a drop of water form on your hand because there's going to be a certain amount of water molecules in the air. When we looked at that, that was one of the reasons why we went to a completely different design of our air vent. We went to a singular conical float so that the chamber at the bottom becomes the sealing mechanism. So when water comes up to the unit, it pushes the whole conical float up and corks off our unit. So ours does not have any type of drip-related issues to it. The other manufacturers have had to do that by their product accommodation, by adding different components to prevent them from leaking. Now, the only issue that I've seen in the field, and this is something I've tried to stress, is when the units are installed, the only ones that I've ever heard of failing in the field have been ones that have been installed like at an angle, or they have been fed wrong. They were piped in arm under arrangements, or they came off the pipe at a sidewall connection, or they came off at an angle connection, such that the float mechanism could not operate properly. That's why I stress the fact that when you are installing these units, they really should only be installed in a vertical format. That's actually very critical.
Okay. Well, Jim, that's the last of our questions that we have for now. So I'm going to try and give everybody 13 minutes of their day back. So, Jim, thank you so much for doing our presentation today. And
Sure.
As always, to our attendees, thank you so much for taking time out of your busy schedule to be with us. So until next time, be safe, stay healthy, and have a great weekend. Goodbye now.